Hello everyone and welcome back to Vector X Academy. This is Satyatej and today's class we will be learning on relations and functions. So let's get right into it. Before we go into relations, let us talk about another operation called multiplication of sets. For example, let us take two sets A and B. A equals to A comma B comma C and B will be 1 comma 2 comma 3. Then we define A cross B as set containing A comma B such that A belongs to A comma B belongs to B. For example, let us compute A cross B for these two. We will get A cross B as A comma 1, A comma 2, A comma 3, B comma 1, B comma 2, B comma 3, C comma 1, C comma 2 and C comma 3. Therefore, cardinality of A cross B will be cardinality of A into cardinality of B. Now let us talk about relations. What is a relation? The definition of relation is a relation R from A to B is a subset of A cross B. We call it a relation from A to B is a subset of A cross B with some particular elements. Now, for example, let us take A as 1 comma 2, B as A comma B. Then relation R from A to B can be 1 comma A and 2 comma B, 1 comma B. This can be a relation from A to B. Now let us talk about types of relations. Mainly the questions to mains and advanced will come from these types of relations. First one will be identity relation. A relation R with such that it contains all sets A comma A such that A belongs to set A. For example, let us take set A as 1 comma 2 comma 3 comma 4. Then identity relation on set A will be R equals to 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4. Second one, reflexive relation. Reflexive relation is such that reflexive relation on A will be R equals R will be a superset of identity relation. For example, let us take A as 1 comma 2 comma 3 comma 4. Then reflexive relation R will be like set contains 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 with some other elements like 1 comma 2, it can be 3 comma 2. Now this set we will call it as a reflexive relation. A comma A should belongs to R. That's it. Third called symmetric relation. A symmetric relation is such that if A contains A comma B comma C comma D be a set, if the relation contains A comma B, then it must also contain B comma A. Example, if R is A comma B, C comma D, then this R also must contain B comma A and D comma C. One, transitive relation. If a relation contains A comma B and B comma C, then the relation also contain A comma C. This is called transitive relation. For example, take A as 1 comma 2 comma 3 comma 4 comma 5. If a relation R contains 1 comma 2, 2 comma 3, 4 comma 5 and 5 comma 1, then to be transitive, it also must contain 1 comma 3 from these two and 5 comma 3 from this and this and 4 comma 3 from these two. We call a relation called equivalence relation if the relation is symmetric, transitive and also reflexive. Then we call that relation as equivalence relation. Now we will learn about domain, codomain and range. Of a relation. First, domain of a relation. We denote it as DOM of R, and the definition is for a relation R from A to B, we call domain of R as all A belongs to A such that A comma B belongs to relation, and for some B belongs to B. For example, let us take A as 1 comma 2 comma 3 comma 4 comma 5, B as A comma B comma C. Then and let us take a relation 1 comma A, 2 comma B, 3 comma C, 4 comma A, and 3 comma B. Then for this relation, domain of relation R will be 1 comma 2 comma 3 comma 4. Since these are in the now codomain of a relation. Now if R is a relation from A to B, then we call B as a codomain of a relation. Range. If R is a relation between A to B, then the range of R will be set containing B belongs to B such that A comma B belongs to R for some A belongs to A. Let us take the above example. R as 1 comma A, 2 comma B, 3 comma C, 4 comma A, 3 comma B, 3 comma B. Then the range of R will be A, B and C. Now we will talk about functions in maths. Now we will talk about functions. What is a function? Now we can take it as, we can say function as the relation which gives output when we give an input. For example, if there is a relation 1 comma 2, 2 comma 3, 3 comma 4, we call this as a function such that if we give an input f of 1, it will give an output 2, f of 2 will be 3, f of 3 is 4. We call this as a function. Now mathematically, for the mathematical definition, we say a function from A to B is such that f of x equals to y for x belongs to A and y belongs to B. The property of function is for each x there is only one y. Now this is a basic definition of a function. With this we can complete the sets, relations and functions topic. So we will go into miscellaneous questions. Types of functions. The first one is one-to-one function. For this, a function from P to Q is said to be 1 1 if for each element of P there is exactly one distinct element of Q for the function. For example, we can, by mapping, if we take this as P, this as Q, assume 1 2 3 as elements of P and A, B, C as elements of Q. This will be an one-to-one function. Example, we can take another example. Let us take 1 2 3 as P, Q as A B C D E. Then this is also a one-to-one function. 1 goes to A, 2 goes to C, 3 goes to E. Now similarly for this relation, same sets A B C D E. Now this is not a one-one function. Since elements 1 and 2 of P goes into same element A, so this is not a one-one function. Second, many to one function. Opposite of one-one function. A function which maps two or more elements of P to Q. We call it as many to one function. Example, let us take the same sets P and Q. 1 2 3 A B C D E. Two or more functions goes to same element of Q. This is a many to one function. Now third one, onto function, onto or surjective. Onto means a function which every element of set Q is a pre-image of P. Like the elements of P will go into every function in Q, every element in Q. For example, let us take P as 1, 2, 3, Q as A, B. Then onto function will be like every element of Q will be covered in the relation. This is an onto function. Simply we can say as range of a function is whole set Q. Range of function from A to B is the whole set B. We call it as onto function or surjective. Also, the another name for one function is injective. Now, if a function is both injective and surjective, we call it as bijective function. Bijective function. A function which is both injective, surjective is called a bijective function. For example, let us take P as A, B, C, Q as 1, 2, 3. Then a function is said to be bijective if it is both injective and surjective. That means the mapping should be like this. A, B, C, 1, 2, 3. Every element of A goes to only one element of B that is distinct, and every element should cover. This can be a bijective function. Now we will solve problems. Let A equals to minus 3, minus 2, minus 1, 0, 1, 2, 3 and R be a relation on A defined by Rx x comma y belongs to R if and only if 2x minus y belongs to 0 comma 1. Let L be number of elements in R and M and N be minimum number of elements required to be added in R to make it reflexive and symmetric. Then L plus M into N will be. No. Generally x r y is also known as x comma y belongs to R. They are saying that instead of for writing easiness we generally write it as x r y. Given A equals to minus 3, minus 2, minus 1, 0, 1, 2, comma 3 and said that 2x minus y should be either 1 or 2x minus y equals to 0. That implies y equals to 2x. From here we can get relations as if x is minus 1, y is minus 2, 0 comma 0 and 1 comma 2. These three will be the AS elements. And from here 2x equals to 1 plus y. That means if we take y equals to 0, no problem. Y equals to 1, x equals to 1. 1 comma 1. If y is 2, we cannot take. If y is 3, then x will be 2. 2 comma 3. Similarly, if y is minus 1, x will be 0. If y is minus 3, x will be minus 1. Therefore, relation R is 1 comma 1, 3, 0 comma minus 1, minus 1 comma 3, minus 3, minus 1 comma minus 2, 0 comma 0 and 1 comma 2. Number of elements will be 1, 2, 3, 4, 5, 6, 7. L equals to 7. We can well write it. L equals to 7. Now, M is a number of elements required to make it reflexive. Therefore, we have 1 comma 1 and 0 comma 0. We need 2 comma 2, 3 comma 3, minus 1 comma minus 1, minus 2 comma minus 2, minus 3 comma minus 3. 1, 2, 3, 4, 5. We need 5 elements to make it reflexive. Therefore, M is 5. And to make it symmetric, we need elements 1, 1 is there. If 2, 3 is there, we need 3 comma 2. And if 0 comma minus 1 is there, we need minus 1 comma 0. We need this one, minus 3 comma minus 1. Minus 3 comma minus 1. Minus 2 comma minus 1 for this and 2 comma 1 for this. That means we need 1, 2, 3, 4, 5. 5. 5 in total. Therefore, n also will be 5. Therefore, n plus n, m into n equals to 25 plus 7, 32. The answer is 32. Now we will go into next question. Let f be a function such that f of x plus 3f of 24 by x equals to 4x. Then they are asking f of 3 plus f of 8. Now here 24 can be written as 3 into 8. Therefore let us substitute x equals to 3. We will get f of 3 plus 3 times f of 8 equals to 12. And if we substitute x equals to 8, then we will get f of 8 plus 3 times f of 3 as 32. Now let us try to get f of 3 and f of 8 from these two equations. This is 1, this is 2. Now we will subtract 3 times into 1 minus 2. We will get 3 times into 1, 3f of 3 plus 9f of 8 minus f of 8 minus 3f of 3 is equals to 12 3 is 36 minus 32. We will get 8f of 8 is equals to 4. That means f of 8 is 1 by 2. Therefore f of 3 will be 12 minus 3 by 2. 10 minus 1 plus 1 by 2. 51 by 2. That means f of 3 plus f of 8 will be 11. That's it for today. This completes our functions, sets and relation topic. And into next class we will discuss on new topic. Thank you all and bye bye.